Question: what's the most abundant energy source in our solar system? Here's a hint. It's 1 million times bigger than the Earth, and without it, our planet would be a dark, cold rock floating in space. You guessed it, the incredible, brilliant sun. The Earth gets more energy from this ball of fire and gas in one day than the whole world's population uses in an entire year. Every living thing depends on the sun for its existence, from tiny microbes deep in the ocean to plants, animals, and people. Humans have been tinkering with solar energy since the dawn of time. Ancient civilizations used glass and mirrors to light fires, but it wasn't until the 1950s that technology was developed to convert the sun's energy into electricity using photovoltaic cells. Today, solar technology is more efficient and less expensive, and is used all around the globe to create electricity, heat water, cook food, and even power vehicles. So how do solar panels usually work? When the sun hits a solar panel, material inside, usually silicon, absorbs the energy. This causes the electrons in its atoms to get very excited and start dancing around. The atoms then get hot and shed the electrons, which travel out of the panel, through copper wiring, and zap! We have electricity. A control device, called an inverter, changes this electricity from direct current to the alternating current we use. The electricity then passes from breaker boxes to outlets and into electrical items, like your computer and lights. Whatever you don't use can go back into the grid to be used by someone else. So there you have it, the amazing power of the sun. Some people see a future where most of our energy can come from this pollution-free and renewable resource. And that's a sunny outlook that will make the whole world smile. We've been harnessing the wind since the ancient Egyptians used sailboats to travel, and windmills were used in agriculture in China over 2,000 years ago. Americans were using wind turbines to produce electricity as early as the 1800s. You may have seen fields of turbines in wide open spaces where you live, since more than 3/4 of US states produce wind energy on a large scale. They may look small from a distance, but a modern turbine can be as tall as a 20-story building, with airplane wing-shaped blades that are as long as a football field. The blades spin at a slow speed of about 1 revolution every 3 seconds. A computer inside the box that sits at the top of the tower controls the direction of the blades to make sure they capture the most wind possible. The blades are connected to faster spinning gears inside the box that create kinetic energy. A generator converts that energy into electricity, which travels down the tower through a cable. The cable connects to the power grid that serves our communities. See? All it takes is a little fresh air to make the turbines go round. Renewable Energy 101. If you've ever observed an erupting volcano, or the geysers at Yellowstone National Park, you've seen geothermal energy in action. The Earth's crust is made of rocks and water. Deep below that is a layer of hot, molten rock called magma, which is even hotter than the sun's surface. The heat just over 6 miles below the surface contains 50,000 times more energy than all the oil and natural gas resources in the world. Releasing a small amount of that heat in the right way can create electricity. A well drilled a couple of miles deep can capture the rising hot water and steam. That steam spins a turbine, and a generator produces electricity. Geothermal is one of the least explored sources of renewable energy in the US, and most of us probably don't spend much time thinking about it. But since it's a pollution-free, renewable source of energy that's consistently reliable, at least it has been for the past 4.5 billion years, maybe we should. Renewable Energy 101. Water covers 71% of the Earth's surface and is vital to our daily lives. It can also be a clean, renewable, reliable source of electricity. Hydroelectric energy comes from capturing the force of moving water that's in our Earth's rivers and oceans. We do this by using the movement of the water to spin hydraulic turbines. That generates kinetic energy, which is converted to electricity through a generator, and then sent to the power grid. Most hydropower is generated from dams built on rivers and streams, often where there's a big drop in elevation, so gravity can help us out. Dams block the water's natural flow and force it through a large pipe with the turbine and generator, before releasing it back into the stream on the other side of the dam. Today, we know that dams, most of which were built before the 1960s here in the US, can disrupt river ecosystems. There haven't been many new hydro plants built in the US in a few decades, but some existing dams are beginning to be tapped for their electricity generating potential. And existing hydro facilities are being upgraded to be less harmful to plants, fish, and wildlife. This helps us get the electricity we need while protecting the natural environment around us. Now that's a win-win. Renewable Energy 101. Biomass, the original renewable energy. It's been part of our lives since our ancestors learned to control fire. In fact, it's made possible by the sun, whose energy is absorbed by trees and plants through photosynthesis, and then released when organic matter is burned or decomposes. First, there's plant waste. Wood scraps, sawdust, and crop waste can be collected from farms or manufacturers. The waste is burned to heat water. The hot water creates steam. The pressure of the steam spins a turbine. The turbine powers a generator. The generator creates electricity. Simple, really. Next up, animal waste, also known as the problem of cow poop. The solution? Waste from farm animals can be collected in a large tank called a digester, filled with bacteria that eats the waste and converts it to methane gas. The methane is captured and burned to heat water and create steam. Sound familiar? Second verse, same as the first. This same principle can also be used to capture methane, a potent greenhouse gas with 25 times the heat-trapping ability of carbon dioxide, from landfills. Once a section of the landfill is closed off, pipes are run from the waste to collect the gas, which can then be burned to make electricity or heat. Biomass may not be the prettiest form of renewable energy, and it needs to be used carefully and thoughtfully to protect ecosystems and prevent greenhouse gas emissions. But it can be a smart way to make use of waste. Power to the poop!